We are now just moments away from the spacewalk number 2 of the Hubble repair job. And you're looking at a live picture from the CNN, Space Center there. CNN science correspondent Miles O'Brien has been keeping an eye on Endeavour. Miles, exactly what's going on right now?
Brian, the second spacewalking duo is suited up and breathing pure oxygen inside the airlock of the space shuttle. Tom Akers will be joined by Kathy Thornton, known to most people at NASA as KT. That's Tom there, there's Kathy. NASA says they may begin their spacewalk in less than a half an hour. Like last night, more than an hour ahead of schedule. Last night they started early and worked overtime. NASA is calling the end result a 100% success.
You've got a yaw maneuver coming up at 1930.
After a successful spacewalk filled with space work, orbiting Mr. Goodwrench's Story Musgrave and Jeff Hoffman got a promotion from beaming brass at Mission Control.
Jeff and Story today have definitely earned their Dr. Goodwrench certificates, and Service Station Endeavour has qualified for a AAA rating.
The other spacewalking duo, Kathy Thornton and Tom Akers, will get a chance to earn their space repair PhD during the next spacewalk. The goal? To replace Hubble's wing-like solar arrays. The plan called for Akers to unplug electrical connectors and mechanical latches holding the arrays in place. Then have Thornton, riding at the end of the mechanical arm, pull the arrays off and stow them away.
Endeavour Houston, we have good elbow camera.
But while one of the old arrays rolled up neatly like a shade, its warped twin refuses to retract, so Thornton will have to let it float overboard.
She'll let go of it and it's going to stay right there. We're going to do a small maneuver just to separate away from it.
The solar arrays are a top priority repair. They jiggle every time the space telescope passes from day to night and vice versa. It means scientists using Hubble must contend with this 30 times a day.
Now the arrays have been redesigned, and so that moving due to this thermal expansion should not be a problem.
This circular fitting is where a solar array attaches to the Hubble Space Telescope. It and the latches on the array were designed for easy operation by an astronaut in space. The hard part for the astronaut comes once the array has been removed from Hubble, because moving anything that large in weightlessness is very difficult. During spacewalk number 1, the staff of Endeavour's orbiting garage made it all look easy. They did everything they set out to do, replacing some crucial gyroscopes and their electronics, with only one snag. When it came time to button up the thin bay doors at the base of the space telescope, a latch was askew.
What was happening is that the doors were not completely closing, and therefore when they tried to do this, this came down about 1 centimeter short.
NASA believes the doors may have changed shape while they were open, exposing each to drastically different temperatures. After about 2 hours of pushing and pulling, the doors were sealed up. Ground controllers are proud to say the fix-it scheme was devised in orbit.
We've encouraged the folks to be able to react without saying, "Mother, may I?"
Amid all the work, there was some time to remember loved ones back home. Jeff Hoffman's wife, Barbara, is celebrating a birthday today. She got a greeting card from her husband, which she will likely never forget. Once Thornton and Akers pop the hatch on the airlock, they will set up and then start working on the stuck solar array, which will be dumped overboard no earlier than 11:43 p.m. Eastern Time. Brian?
Miles, what is new and improved about these solar arrays that you're talking about?
Two things. First of all, they put some thermal protection on the stems along the side of the solar arrays so that they probably won't move as much. The second thing that they've done is that they've installed some springs, so whatever movement there is when it goes from day to night or vice versa will be lessened somewhat. The idea is that it'll keep a steady eye on the stars and out beyond at the edge of the universe.
Okay, thank you very much. CNN's Miles O'Brien, and of course, CNN is following what's going on up in space, and we will keep you informed. Gene?
Big doings up in space at this very moment. We go to CNN science correspondent Miles O'Brien for an update on Endeavour and the Hubble repair mission. Miles, what's up?
Gene, a little more than an hour ahead of schedule. Much like last night, the airlock door is open and one of the astronauts' head is peeking out. We don't know who it is yet, and not much work has begun just yet. Undoubtedly, what the astronauts are doing right now is checking each other's suits out to make sure that they are operating correctly. This is the highest priority task that the astronauts will attempt tonight, and that is the replacement of the solar array panels on the Hubble Space Telescope. The 350-pound wing-like panels have not been operating properly. They have a distinct jiggle in them when they go from day to night or vice versa. Enough of a jiggle to cause some real headaches for astronomers. It causes a blurred picture, which makes it difficult for them to do their readings when every 90 minutes or so they have a blur. It loses lock on the star they're looking at. The new arrays, which they're going to be putting on, are thermally protected and have special shock-absorbing springs in them, which will hopefully dampen the effects of going from high temperatures to low temperatures and vice versa. You're talking about radical temperature swings in a short period of time, and so there has to be some special design considerations in there. The task is a fairly long and laborious task. It will take up the entire spacewalk, which is scheduled for 6 hours and probably 30 or 40 minutes on top of that.
Miles, what's going to happen to the array they take off?
Well, one of the arrays is, they're designed to roll up like a window shade would, and one of them did indeed roll up like a window shade. That one will be stowed away on board and brought back to Earth, where they will dissect it and try to figure out exactly what went wrong on that one. Another one, however, which was bent and had a distinct kink in a stem which supported the roll-up shade-like panel, was unable to be retracted earlier during spacewalk number 1. And so what the astronauts are going to have to do is toss it overboard, or nudge it overboard, as they like to say. It will be a gentle activity. Kathy Thornton, who will be riding on the end of that mechanical arm, will pull that array with her. The arm will be fully extended, and she will be at the top of that arm with a special handhold on that array, and she will just simply let go, and it will float out into space. The rest of the work will be done by Space Shuttle Endeavour. Dick Covey at the controls will fire a few booster rockets to get the Endeavour out of harm's way so that there's no collision.
Endeavour, we copy that the pressure.
Any risk, Miles, that array could collide with the shuttle?
Well, NASA would like to minimize the risk. One thing they're doing to ensure that there isn't a collision between the two is they're going to begin this procedure of jettisoning right as the Endeavour astronauts encounter their dawn. That'll happen at about 11:43 p.m. Eastern Standard Time tonight. They want to maximize the amount of daylight they'll have when this maneuver occurs so that they can maintain visual contact with that array for as long as possible. It's a pretty straightforward maneuver for Dick Covey. After all, he was able to maneuver the Endeavour to the Hubble Space Telescope with great aplomb just the other night in the rendezvous, and this should be a pretty easy trick for him.
16.8, amps 3.4.
We're going to continue to keep our eye on this, and we'll give you an update as soon as we see a little more from the cargo bay area of Endeavour and as the big task begins as we continue on CNN tonight. Brian?
The shuttle astronauts are back at work on the Hubble Space Telescope, and you're watching live pictures right now. Their first repair mission was a success. The U.S. Space Agency NASA hopes for a repeat performance. And as you can see, the astronauts are out at work on their spacewalk. Immediately following World News, in some 20 minutes, we plan to bring you live coverage from the Endeavour cargo bay as the shuttle crew continues its groundbreaking repair mission in space.
Here's the live picture from Space Shuttle Endeavour as two spacewalking astronauts continue to do their work to repair a solar panel, remove it from the side of the space shuttle, and toss it off into space. Let me bring you up to date as to what's happened during the past 30 or 35 minutes. Astronaut Kathy Thornton has gone out into the cargo bay. That is Kathy Thornton that you see there attached to the shuttle's robot arm. She's about to release the broken solar array from the space telescope. She's having to disconnect it while the shuttle is in darkness. You can see it's the dark of night there right now, and this operation has to be done in darkness because what's going on is that electrical wires from the solar panel to the batteries inside the telescope are being disconnected. If you were to do this in daylight, the solar panels would be generating electricity and the astronauts could possibly get shocked. Thornton is pulling the electrical plug along with Tom Akers, her colleague outside, which connected the panel to the telescope. And as soon as that is disconnected, Thornton will take the solar panel in her hands and hold it out over the cargo bay. As soon as the sun comes up, Thornton will let go of the solar panel and it will float free. I think probably what we should do is listen in, because there have been a certain number of problems out there in space, one of which Thornton's two-way radio receiver in her helmet are not working at this point, and so she can't hear the ground. She can hear Tom Akers, her partner, outside, but let's listen as the ground controllers and the astronauts attempt to get this solar panel loose from the side of the telescope.
Okay, what's with that? Torque on 2. Torque limiter. It's there. Double check, I'm on the right side, so this will be a loop. And a power tool on low speed, Story.
Now, what we are looking at is the connection point on the side of the Space Telescope where the solar array hooks up to the telescope.
Preparing to release the final clamp for the array, where it will be held freely then by mission specialist Kathy Thornton.
That's Kyle Herring, the NASA mission commentator for this spacewalk, announcing that one of the final clamp holding the solar array to the side of the telescope is coming loose.
I'm going to tighten it back a half turn. I didn't like it.
What we're watching right now will probably be one of the most critical moments in this entire space shuttle mission, because this solar array didn't operate the way it was supposed to from the beginning. It should have retracted itself into a cassette so that the astronauts could have brought it home on board the shuttle, but because of a kink in one of the support rods for it, it couldn't be retracted. So they're going to have to dump it overboard, leave it out in space, which they'll be able to do as soon as they get it disconnected from the side of the Space Telescope, and as soon as the sun comes up, so that NASA managers can watch it leave the shuttle in daylight.
There, I got the lock wire, one piece, Story. Okay, coming into the bag. I just hope it stays there. Close it up quickly. Okay.
It appears the solar panel is just about to come free. This spacewalk will probably be the most complicated for the astronauts of all that they are preparing to do. The 40-foot-long solar panels have provided electricity for the telescope and kept its batteries charged consistently, but they vibrate every time the telescope moves from darkness into light and back again. The replacement solar panels have springs along the outer edges of the support poles, which should stop this shaking once they get installed sometime in the next 5 hours.
Okay. Now, KT, we're really ready. Ready? Bayonet check. Looks good. Okay. Double check direction again. 1 second. Okay. All right. Move me about 6 inches toward my head, please.
We're going to have a lot of help in our coverage tonight. Joining us to enhance our coverage are two astronomers from the Fernbank Science Center in Atlanta, David Dundee and Anita Kern. They're experts on astronomy from Earth and space, and they're in the know on what the Space Telescope has done so far and what it will be able to do after it's fixed. Coming up a little bit later in our coverage, we'll be joined from the Johnson Space Center in Houston by Ed Weiler, who's the NASA program scientist for the Hubble Space Telescope, and he's helped us understand this machine and its capabilities since long before it was launched 3.5 years ago. All right, they're about to remove the solar panel.
2, 3, 5, 6. Lamps opening. 7.
The astronauts are counting as they turn a device that releases this latch.
10, 11, 12, you might hold in towards me this way, KT. 13, 14, 15, 16, 17.
17 turns so far of a screw holding the latch in place.
19, 20, 21, 20 and 1 1/2 and a soft stop store. Okay, the stanchion is touching your GFR. Yeah, I can feel it down there. Okay, KT. All right, KT. It looks clean. I can see what direction Clyde needs to go first to clear your GFR. You need to go forward. Well, let me look. You need to go down. Okay.
You can probably see now the solar panel
array
is
now,
flapping.
Coming loose is it's just freely held by Mission Specialist Kathy Thornton at the end of Endeavour's mechanical arm.
Okay, can you take you down? Down your few inches, Clyde. Are you clear? Okay.
So it appears the solar array is going to move away from the telescope now as Claude Nicollier, the Swiss astronaut, controls the robot arm to pull it back from the side of the telescope.
Down and forward if you can, KT. I'll stabilize it here.
We're gonna take a break right now, and when we come back, the sun will be rising over the space shuttle, and we'll be able to watch Kathy Thornton toss this solar panel overboard. Stay with us. Our live coverage from Endeavour and CNN will continue in just a minute.
Let's do this with your hand.
Welcome back. We're looking now again at live picture from the Space Shuttle Endeavour. What you can see is astronaut Kathy Thornton out at the end of Endeavour's robot arm, moving away from the space telescope with the solar array in her hands. Let's listen.
Her in the orientation she is with her head toward the port side.
You can't see too clearly because it is still dark in space where the shuttle is flying right now. But the sun will be coming up in a matter of minutes, and we'll have a brightly lighted picture to show you as soon as the sun comes up to illuminate it. NASA ground managers told us they anticipated the sun would come up about a minute from now. Removing this solar panel from the side of the telescope was a little bit more complicated than anticipated for a couple of reasons. One, the solar array is not in its cassette. It's broken, it's misshapen, and it wouldn't roll up like a window shade does when you raise the window shade. It's partially extended still, making it much more difficult to work with.
Endeavour should be moving into sunrise in just about a half a minute now. Again, the release of the array will not happen until daylight in order to provide good visibility for Commander Dick Covey and the crew as they release it, and Covey flies Endeavour away.
Well, Story, nothing's easy.
The astronauts out in space are talking to Story Musgrave, the payload commander, back inside the shuttle, saying nothing's easy. What a picture. Look at this. You can see Tom Akers there just holding on to the side of the space telescope, sort of almost like he's flapping in the breeze, although there is no breeze where he is right now. And at the top of your screen is the robot arm with Kathy Thornton, and the solar array is up there, but you can't see it because it's dark. NASA commentator Kyle Herring was just telling us what I told you a few minutes ago, that the sun is supposed to come up any second now. And as it comes up, we'll be able to see all of this better. As you heard Kyle Herring say, the reason the sun has to be up is that the shuttle, what's going to happen is that Kathy Thornton will let the solar panel go. She doesn't really have the strength
James, you can
to
see in
push
this
it away.
view that Kathy's having absolutely no problems holding on and maneuvering the solar array to the position from which they will release the array and then have the orbiter back off. At the same time, Tom Akers is continuing to do preparations for remounting the new array into the position from which this one came. And it's, in all likelihood, he'll probably go around on the other side of this satellite and continue the preps for the removal and replacement of the other solar array.
This is astronaut Jerry Ross, who is
Copy, we
doing
like
color
your plan.
commentary
we
for
also
NASA
want
tonight.
to make sure that the array does stay parallel to the body y-axis. And as a note for Claude, after jettisoning the array, if he goes ahead and flies directly to the position on page 4-20, he will avoid a reach limit.
You could go with one here at arm's length. Okay, roger that.
At any rate, we were talking about the reason that the sun has to be up to let this thing go. Shuttle Commander Dick Covey will fire a small rocket on the shuttle to move the shuttle away from the array. And after that
dawn
maneuver,
is now broken on board Endeavour.
after that maneuver, the two pieces of equipment will be separated. The solar array will be gone and out of the picture, and about a year from now, it'll fall into the atmosphere and probably burn up.
Which it's kind of halfway. I guess got off the ground, that story. I had a lot of trouble getting the pip pin pulled out here. Had to take two hands to pull it through the plastic part. It's not binding on the pip pin action itself. It goes down in real smooth into the change-out position, but it would be really tough with one hand. I think impossible to get out if it was fully seated. Halfway seated, it's a maybe.
That's astronaut Tom Akers, who released the solar array from the side of the telescope. He's got to do this very carefully because all those same pins and connectors have to be used to hook up the replacement new solar array, which the astronauts will be bringing out in sometime in the next hour and a half. So although
They're talking about it, KT.
Mission Control tells us that the sun is up, it's hard to tell that from the position where we are. The shuttle is flying right now with its tail facing the Earth and its nose pointing away from the Earth.
At the Houston copy store. I'll check. Hey, I'm going to head on down. I'll come back and configure it however they want before we put the new one in, okay? Get up here.
You can see there astronaut Kathy Thornton holding the solar array with a triangular device, looks sort of like a musical cymbal that's connected to the solar array and connected to each of her hands.
Hey, Story. I'm checking. Okay. Didn't know if you heard me.
Endeavour Houston with a final refinement on the SEP sequence for Covey.
They're giving some rocket firing commands to Commander Dick Covey right now.
Covey, since we know the Norm Z pulses are going to induce a pitch rate on the array, we want you to use your best judgment in delaying the start of the Norm Z inputs until you are comfortable that the pitching array will definitely clear the top of HST.
This is capsule communicator Susan Helm talking to the crew. That was NASA speak telling Commander Covey he can fire the rockets exactly the right amount of time based on his best judgment, because when Thornton lets go of this solar array, it is likely to spin. And they certainly don't want the array to spin in such a way that it might hit astronaut Thornton or any of the other equipment up there. The robot arm is now as far away from the surface of the telescope and the surface of the shuttle
Sunrise
as it can possibly
be seen on the Earth below, just behind this television from Endeavour, behind mission specialist Kathy Thornton. This Endeavour continues across the northern Sahara Desert, about to cross southern Egypt.
And James, this is one of the favorite times for an EVA crew person because they're waiting for things to happen that gives them a chance to look around a little bit and enjoy the beautiful views that you've got out there. Instead of having to go from window to window inside the orbiter, all you have to do is kind of move your head around inside your helmet, and you have essentially a 180-degree view of the beautiful Earth below you.
Endeavour Houston for RMS.
Now you can see the solar array very well in the sunlight.
So the simplest thing to do is after release, bring KT straight down with the Z down input.
Okay, I'll do that. Straight down after release.
That was the voice of Claude Nicollier, who's operating the robot arm.
Is our best guess.
Okay.
I wonder if Kathy Thornton's getting cramps having to hold her arms above her head this way for so long.
And Jerry, in this view, it would seem like it, with the array being such a long object, it could be difficult to keep it stable. However, it's remaining rock solid. Is that the truth? Is it difficult to keep it stable in that position?
Actually, not at all, James. In zero gravity, it takes a force to either start or stop a motion, but once you have it stopped, it takes absolutely no force at all. So probably Kathy is not holding on with any more than some very light finger forces so that she doesn't perturb the array, and that makes it much easier and less fatiguing to her hands.
Again, as the last call from Endeavour indicated, the crew's standing by to let the sunlight become a little more direct before initiating the release and jettison of the array, at which point Commander Dick Covey will fire Endeavour's jets very slowly at first to begin moving away from the solar panel, gradually increasing that. Flight controllers expect that as Endeavour begins to move away with increasing rapidity, picking up a little bit and it's moving away, the firing of Endeavour's steering jets may cause the array to spin slightly. That's not a problem at all if that occurs, and it is expected somewhat as a result of the jet firings when Endeavour departs the vicinity.
Okay, Tom. Tell KT go for release. Okay. Can then hang on one sec so I can get
Here we
one
go.
watch.
Watch closely. You'll see Kathy Thornton let go of the solar array in just a matter of seconds.
Okay.
There's a communications problem in Thornton's helmet,
Okay,
space
KT.
helmet on her spacesuit. She can't hear the ground.
Yeah, I'm ready. Okay, they say you got to go for release. Expect 20 pulses on your RHT. Hey, no hand. It is going to be
There it
20
goes.
pulses on the RHT for a set burn. Okay.
The solar array is not moving, by the way. The reason the picture is moving is you're seeing a camera attached to the robot arm that was moving Kathy Thornton away from the solar panels. What will happen next is that Commander Dick Covey will fire a jet on the shuttle that'll move the shuttle away. And it could be that the exhaust from that jet will hit the solar panel and cause it to spin a little bit. But you can see the solar panel beginning to disappear in the upper right-hand corner of your screen. And astronaut Kathy Thornton is sort of under the word Endeavour on your screen down at the bottom. And you see
Endeavour
planet
now
Earth
backing
there in the
away
background.
from the array.
Pretty neat job, KT.
Again, it's expected that
What are you going to do when it starts flapping in the breeze? I
There
just
it
don't
goes.
know.
The panel starts to flap as the shuttle moves.
Endeavour steering jets causing the array to wobble. It's expected to spin, and also with that spinning motion, the spinning motion is anticipated to make it re-enter the Earth's atmosphere quicker as well.
Look at that picture.
It's expected that this array will re-enter and burn up in Earth's atmosphere within a year or so.
The multi-million-dollar European-built solar array probably will never be seen by human beings
Endeavour,
again
check free drift.
after it floats out of view here. As it goes away over the Earth's horizon, we'll take a break. We'll be back with more of our live coverage from Endeavour,
That the
Space
plume from
Telescope,
Endeavour's
and
jets hitting
CNN
the array
in just a
as
moment.
it
Stay with us.
continues to move away.
Looks like a bird, Tom. Look at it.
Live from Endeavour, you were watching a solar array which was attached about 5 minutes ago to the side of the Hubble Space Telescope. It's now been removed, jettisoned by astronaut Kathy Thornton, and it is spinning in space as it moves away from the shuttle.
Well, that's okay. We know what that's like, don't we?
Astronauts today a little looser than they were last night. They're joking back and forth with each other. Thornton, as she watched this solar panel flop in the breeze or in the weightlessness of space as it floated away, said it looks sort of like a bird. And it does. It's out on the horizon of the Earth, is there on the left-hand side of your screen, and the solar array is in the darkness
I'm going to be
above
right
the
up
Earth.
here at the TSB to hand you the transfer handle if that's about as good a stable place as I can get, I think.
While we're watching this
There when
picture
they
from
get
space,
ready.
The astronauts in the cargo bay are preparing to bring out the replacement solar panel, the one that shouldn't have the jitters that this one had, and attach it on the side of the telescope. There are two separate solar panel arrays attached to the telescope, or there were before this one left, and both of them will be replaced over the next 3 or 4 hours. A picture like this, never before seen by human beings. It's quite something that we get to watch it together as this 40-foot-long solar panel continues to spin away from the shuttle.
That's a good flex point. In fact, I'll just go get my PFR, KT. That's just as easy as this TSB, right?
With the array jettisoned, the next task for the crew now is to replace it
Back there, KT.
and install the new array for the telescope.
Yeah, you're incredible.
The new array must be removed from its carrier, which is located in the forward part of Endeavour's cargo bay.
All right, we're going to take another break. We'll be back with more live coverage as the astronauts continue this job. The most complicated task of their spacewalk has been completed now, and if no more problems develop, it could be just like clockwork for the next 3, 4, or 5 hours.
Okay, we copy that.
We'll be back. Stay with us.
Astronauts from the Shuttle Endeavour have just had another dramatic success in their work on the Hubble Space Telescope. A few minutes ago, astronaut Kathy Thornton performed a breathtaking feat. A 40 solar panel was unbolted from the Hubble telescope. On command from the ground, Thornton let the panel go free. The shuttle then fired its rockets to move away from the floating solar array. The rocket exhaust hitting the panel caused it to slowly tumble as it drifted away from Endeavour. On Saturday night, 2 other crew members put in almost 8 hours spacewalking to repair the bulky telescope. NASA characterized their efforts as 100% successful. And at the bottom of the hour, we will continue with our live coverage of the repair of the Hubble telescope.
Hello, it's John Holliman at the CNN Center in Atlanta, welcoming CNN International viewers to our CNN United States viewers as we continue to cover the repair mission of the Hubble Space Telescope. Let me bring you up to date. In the past hour and a half, spacewalking astronauts Kathy Thornton, who you see at the top of your screen attached to the Endeavour's robot arm, and astronaut Tom Akers, who you can see moving his right hand in the bottom of your screen just above the word Endeavour, have removed and thrown overboard a faulty solar panel which has been working on the Hubble Space Telescope for the past 3.5 years. What they're doing right now is adding a brand new replacement solar panel to the telescope. It is sort of orange in color or brownish in color. You can see it sticking out above astronaut Kathy Thornton at the top of your screen and about the middle, while down at the bottom of the screen above the word Endeavour, Tom Akers continues to work to attach the electrical connections so that when this solar panel is unfurled a little bit later today or tomorrow, it'll again generate electricity and charge up the batteries aboard the Hubble Space Telescope.
Okay, so it's moving. It's not moving. Have they sent the command? I don't know. They haven't said anything.
Astronaut Kathy Thornton has got a technical problem in her spacesuit. She cannot hear on her two-way radio commands from the ground. So what she can hear is her partner in space, Tom Akers. The ground controllers have to relay word to her through Akers. They talk to him and then he talks to her. It's a little complicated. You'd think it would slow down this repair job, but the astronauts have apparently been so well prepared to do this that Thornton has not had to spend a lot of time wondering what the people on the ground want her to do. She's just been doing her job and doing it quite effectively this morning. The astronauts have been outside for about an hour and a half now. This part of the spacewalk, the removal of that defective solar panel and the reattachment of the new one was supposed to take about 2.5 hours. That's what NASA managers had planned for it to take. But it seems to be moving ahead much faster than anticipated, much as last night's spacewalk did as well. Joining us here in Atlanta, a couple of astronomers from the Fernback Science Center, David Dundee and Anita Kern. Anita, as you watch what the astronauts are doing, and you look at this telescope with its electrical needs, it operates on 28 volts of electricity. That's, I suppose, a totally different sort of electrical system than what ground-based telescopes use, isn't it?
That's true. At Fernbank, our telescope is very simply controlled, and it has we actually have to go in on the night that we're pointing it and set it up by viewing a star that we can see and then entering the coordinates, and then it tracks correctly. But it has a gear mechanism inside it that's fairly simple, and if we want to adjust the drive rate, we have to go to the back and actually look at the gears and determine what rate they're spinning, and we can go to a variable rate on that.
And you don't have to worry about solar panels like this faulty one that we're looking at over your shoulder now. This is what that messed up solar panel looked like as Kathy Thornton and Tom Akers prepared to remove it from the side of the telescope about an hour ago. It has a crimp in one of its support arms, and it was very problematical for the astronauts to get it loose and toss it out into space. But they were able to do that just about right on schedule about 45 minutes ago. Tell me in very clear layman's terms, Anita, what the difference is between the pictures from the Hubble Space Telescope and the pictures of the night sky from a ground-based telescope.
The pictures that Hubble is producing are about 10 times better than the best resolution we can achieve with the Keck 400-inch telescope.
Now, what does that mean? What's 10 times better resolution?
You can see fine detail. For example, if Hubble looks at Jupiter and wants to see structures on Jupiter, it can see structures that are a fifth the size of what we can see from our ground-based telescopes.
Now, how about other planets around other stars? We had a number of viewer telephone calls last night asking whether it might be able to find life on other planets or other planets.
That's one of the most interesting questions that Hubble has to address, and it has already, in fact, seen some evidence to support that there might be planets around other star systems. In the case of the Orion Nebula, which is a gas cloud that many of your viewers are probably familiar with, this is a dust cloud that's about 1,500 light years out in space, and it's actually the middle fuzzy star in the sword of Orion. And this dust cloud, we've known for quite some time, was a stellar nursery, but Hubble has actually looked at the stars in the dust cloud, the young hot stars that are forming, and has seen accretion disks of dust around at least 15 of the stars there, which is, of course, candidates for a possible solar system at some point.
So this might be like a birthing solar system, a series of planets that might be coming up. David, when you look at pictures from the Hubble Space Telescope so far, what's the most interesting thing you think it has shown us here on Earth?
I think the most interesting to me is taking a look at the structure of galaxies, especially the unusual, the strange galaxies like quasars, very, very distant objects, and the very explosive galaxies. And one of the things that Hubble has been able to do is give us clues that there are massive black holes inside of these galaxies, causing some of the strange structures that we saw before on ground-based telescopes that we had a hard time explaining. The Hubble Space Telescope has also shown us something called the Einstein cross, which is an amazing bit of prediction of Einstein. Said that light could be bent by great gravity fields. And what we saw from the Hubble Space Telescope is we had a massive galaxy in the foreground, and we saw on all four sides of the galaxy looked like four duplicate images of a quasar. And what it was the quasar was actually behind this massive galaxy, and the light was being bent around the galaxy and showing these four images called the Einstein cross. And this is something that's never been seen before. And the Hubble Space Telescope may, in fact, give us some clues about the structure of our own galaxy. One of the things we have not been able to do with ground-based instruments yet is look to the very center of our own Milky Way galaxy, even though it's a mere 33,000 light years away. Because of the obscuring dust and gas, we can't see to the very center. And there is a lot of suggestion that there have been some explosive events happening near the center of our galaxy. Now, is that caused by a giant supernova, or is it being caused by perhaps a massive black hole. Are massive black holes normal in large galaxies, or are they just peculiarities? I think the Hubble Space Telescope, during its 15-year tenure in space, may help to answer some of those questions.
And we'll certainly give it every opportunity, perhaps, if this repair mission works out as it is so far seeming to do. What's going on out in space right now? Astronauts Tom Akers and Kathy Thornton are reattaching, or attaching for the first time, a new solar panel to one side of the Hubble Space Telescope. As soon as that is done, they'll remove an additional solar panel from the other side of the telescope, put it down in the cargo bay for return to Earth, and then attach the second replacement solar panel. All of this supposedly will be done in the next 4.5 to 5 hours. The astronauts have nothing else to do but that on this particular spacewalk, but I must tell you, it has been very complicated, complex activity, and they seem to have pulled it off pretty well. We're going to take a break right now if we can. When we come back, we will invite you to join us here and ask questions to our astronomers, or maybe you can ask some question that I might be able to answer. At any rate, this is the number to call from wherever you're watching around the world. Our coverage will continue in just a minute. Stay with us. Participate in our discussion of the Hubble Space Telescope repair mission. This is the phone number we'd like you to call if you want to talk to us. Last night we put this number on the screen, and a lot of people called, hundreds of you called, not only here, but some called other numbers at NASA centers around the country, and the folks at NASA urged us to urge you not to call them with questions if we can answer them here. The reason being they're very busy trying to do these spacewalks and manage them, and they would rather have you call us at this number than any other number for NASA that you might have. So this is the number to call if you want to participate in our viewer call-in here with our two astronomers as we continue to watch the Endeavour astronauts do their work to repair the Hubble Space Telescope. So far, pretty good work for the astronauts over the past hour and 42 minutes. They have replaced a faulty solar panel aboard the Space Telescope, thrown it over the side. At this point, we don't have live pictures from space to show you because the Endeavour is out of satellite range. But as soon as we do get more live picture, we'll have that for you, and we'll be playing back some of the more exciting pictures from the past couple of hours. We have a viewer in Colorado who'd like to join our discussion now. Go ahead.
Yes, I'd like to ask, when astronomers use the telescope from different countries, are they billed for that time? And also, who are the voices of Capcom? Are they astronauts too?
Okay, I think I can probably answer both of those questions. Yes, they are billed. Astronomers from various countries participate in the telescope by signing up. In fact, I guess the telescope time is booked so far in advance. It is booked up probably for the next 3 to 4 years with people who know which 15-minute period they're going to get to use the telescope, and sure, they have to pay for it, maybe not the whole cost, but some cost. And the people who are talking to the astronauts generally are astronauts. Right now, let me see, Greg Harbaugh is the man who is communicating up with the Endeavour astronauts. He was the 7th astronaut designated for this mission. He was the extra astronaut who was in training with these people throughout their entire training to repair the space telescope. He's qualified for spacewalks, and he knows as much about what's going on in space as they do, and consequently, he's the right person to be talking to them tonight, and he's the capsule communicator. Susan Helm, another NASA astronaut, was talking to the Endeavour crew a little bit earlier, maybe 2 or 3 hours ago. But that is the way it works. They generally have an astronaut on the two-way radio relaying messages from Mission Control in Houston. We have another call. I've forgotten from where. From Florida. Go ahead. Go ahead from Florida.
Yes, so I have two questions, really. One, my first question is, why don't, it seems like very complicated maneuvers are doing up there. Why not bring the the telescope back down to Earth to do these repairs? And secondly, why do they just jettison away the array? It seems like they could salvage that part. It's a very expensive part, I'm sure. Why not save it?
All right, let me answer the second part, and I'll let our astronomers answer the first part, which is why not bring the Hubble Space Telescope home?
Well, the reason is that, number one, the instruments in the Hubble are very sensitive, and the re-entry and then to blast it back off, it's a lot of stress on the telescope. The other problem is that the instruments inside the telescope are made for space conditions. You really don't want to bring it back to Earth, which is a terribly dusty place, that could contaminate perhaps some of the packages on board. That was one of the expensive parts after the Challenger disaster, to store the Hubble Space Telescope for the years that the telescope launch was delayed, was to keep all the instruments in pristine condition away from dust and other conditions on Earth. So no, it would be much better for the telescope to leave it where it is.
And while they're working on it in space, it only has to shut down for about 6 to 7 weeks. And if it were brought back to Earth, it would be out of commission for at least a year, NASA managers tell me. And so it would, all the astronomers who are lined up to use it wouldn't get to use it for that period of time. We're back to live picture, and as we look at what's going on here from space, you can see that the astronauts are continuing to work on reattaching that solar panel to the side of the Space Telescope, and sounds like they're having all the success they're supposed to. We can listen in for a minute and just see what we can hear.
Look straight, KT. Okay. There's one.
The two spacewalking astronauts, Kathy Thornton is at the top of your screen and Tom Akers at the bottom.
Things ought to be starting to compress. Gotta feel it.
The telescope and the space shuttle are in the dark right now, and they're using a spotlight from the cargo bay to provide us this picture. It's a little bit difficult to see with the spotlight.
Looking good. 4.
The astronauts using their power tool to make turns in bolts that will reattach the solar panel.
4, a little over 4.5. Hard to keep track there. Ratcheting. Okay, Yankee and Zulu are on and torque story. I'm going to get the keyholes while KT repositions for W. Okay?
Okay, let me back away from the telescope about 3 feet, please.
Okay.
We'll watch now as the robot arm, operated by Claude Nicollier,
Power tool 3.
moves Kathy Thornton back about 3 feet. Okay, we've got a call from California now. Go ahead.
Hi. Does NASA have a newsletter or a video television station or regular videotapes or something that ordinary people can kind of learn a lot about the Hubble more than they can from the newspapers and stuff?
Yeah, absolutely. NASA has a TV service called NASA Select, which is providing us the pictures that we are providing you right now. It has been a 24-hour-a-day service, but because of budget cuts, it's after this mission, it will only be operating when the space shuttle is in orbit. And so it's a very good way to keep up with shuttle missions, and has been a good way to learn a lot about the space program, available on some cable TV systems around the country. And NASA has a pretty large public relations function, which is comes from NASA headquarters in Washington, D.C. And you could write them, and they'll be glad to provide you with information about the space program. We're going to take a break. We'll be back in just a minute. Stay with us for more live coverage from Endeavour and CNN. The second night of spacewalking to repair the Hubble Space Telescope continues in progress from the Shuttle Endeavour. Right now, astronauts Kathy Thornton and Tom Akers are replacing a solar panel on the side of the Space Telescope. As you know, the shuttle travels around the world every 90 minutes, and right now it's over a part of the planet that is in darkness, which is why it is so dark out there where they're working. There's a spotlight down in the cargo bay shining on Thornton's backpack, and that's providing us with the light we have to see this picture. While the astronauts do their work, I'll continue to pay attention to what they're doing and also take some of your phone calls. We have a caller from Washington now on the line. Go ahead, please.
Hello.
Hi.
I wanted to find out if we're going to be able to get better pictures of Mars and those faces on Mars they saw on those, in the Sea of Cydonia.
Yes, definitely. You should have pictures of Mars that will show some of the weather movements, weather such as it is. Mars does in its summer. The polar ice caps melt and they have a thin atmosphere, and also dust storms are fairly prevalent on Mars, and so we should be able to image those quite well. And we'll determine whether Elvis's face is there or not.
The patterns that you see on Mars, of course, the kind of the humorous bit about faces and pyramids and things, of course, are mountains and crater patterns on Mars. And with enough imagination looking at any cratered terrain, I'm sure you can see all sorts of things. But yes, the Hubble will be able to do some wonderful imagery of the surface of Mars.
But you astronomers don't buy the National Enquirer face on Mars theory, huh?
We don't even rate it as a theory.
All right. Our next caller is from Toronto. Go ahead, please.
Hi. I understand that part of the repairs to the telescope involve something to do with the optics to correct part of the problem that the mirror had to begin with. My question is, how much of a compromise is that going to be in the end?
Good question for our astronomers. Go ahead.
Well, what's going to happen, and I believe it's tomorrow night, is they will insert something called CoStar, which will look kind of like a big phone booth, and that will intercept the light and from the mirror and correct for the slight non-focus properties of the mirror. As far as what we will have to sacrifice, the only instrument that they'll have to remove from the Hubble is the high-speed photometer, and that will reduce the Hubble's ability to see short-scale events, but that's a very minor part of the total package of what Hubble is all about.
Yes, the way the CoStar works is it has it has mirrors that are deployable, and the first mirror intercepts the starlight from Hubble that it has the spherical aberration, and then it focuses that into a second mirror, which then is corrected so that it gives us back the point sources, and then that light is then reflected into the instruments.
All right, Toronto. I hope that answered your question. Now, to Oklahoma for another question.
Yes. Before the launch of the Hubble, I read that the telescope should be able to image Pluto with clarity like we see the moon with the naked eye. Are there any plans to photograph Pluto with the Hubble?
It is.
It has been photographed, and I don't think I've ever heard of it being photographed as well as Pluto, as our moon, but Hubble for the very first time imaged Pluto's small moon, which has never been really clearly seen before. And as far as images like our moon, I don't think Hubble's going to ever quite achieve that. But what will be interesting with the Hubble, it will be able to image on Pluto the small seasons that Pluto has. Pluto's orbit is highly elliptical, and so when it's carried closer to the sun, Pluto for a very brief time has a very tenuous atmosphere, and what happens is some of the ices on the surface vaporize and make a very, very tenuous atmosphere. Nothing even close to breathable, but that will be observable with the Hubble.
Yes, the closest we've really seen to Pluto, probably up to this point, was when Voyager flew by Neptune and photographed Triton, a moon of Neptune, and we felt at the time that was probably the closest we were going to get to seeing what Pluto really looked like.
Let me interrupt the two of you for a second to let you know what's going on in Endeavour's cargo bay. The first solar array has now been connected, and the astronauts are just beginning to clean up their work area there, and they'll be backing away from the new solar array right now. NASA commentator Kyle Herring is talking about this now. We can listen into him for a minute.
At the beginning for setup. Right now it looks like the two crew members are a little bit ahead of the timeline. That even includes the jettison procedure that was added to today's spacewalk, so they are making pretty good time.
Look at the latches underneath.
You know, Kyle, another thing that you're seeing here in very good representation is that we don't stop when it's dark outside. We have very good lighting on the helmets of the suits, and also you can see the very large, bright spotlight that Story Musgrave is aiding the crew with from inside the orbiter's crew compartment. It's a very large flashlight that he's shining out there to help the crew with their visibility.
So the astronauts continue their work out in the cargo bay, and they are ahead of schedule. We're not exactly sure how far ahead of schedule they are right now, but the first solar panel replacement was supposed to take 2.5 hours. They went out into space at just about 11 o'clock Eastern time. It is now just about 1 o'clock Eastern time, so they've been out, they're probably about 30 minutes ahead of their schedule. And what will happen next is the telescope will rotate 180 degrees, and the astronauts will then remove an old solar panel from the other side of the telescope. Our coverage will continue after these messages. Stay with us. Welcome back to CNN's coverage of the Hubble Space Telescope repair mission. I'm John Holliman. We have a couple of astronomers who are experts on ground-based and space-based astronomy, David Dundee and Anita Kern from the Fernbank Science Center in Atlanta. If you'd like to join in our discussion, you can give us a call. We have a phone number that we'll let you know about in a minute where you can call and speak with us here at CNN. Here's the number. It's 404-221-1855. If you want to talk to us, please call that number. Don't call any other numbers. Don't call numbers at NASA centers around the country because they've had some problems with you viewers trying to reach them when you wanted to reach us. We'd really like to talk to you. Our first caller, by the way, is on the line from Oklahoma. Go ahead, please.
Yes, I'd like to tell you that I'm enjoying the show. I'd like to know what the schedule is going to be, telecast schedule for the rest of the week, and also any key events that we might set up, their VCR, or get the kids up to watch.
Okay, most of the things that the astronauts are going to do in space will happen at about this time of night. In Oklahoma, I guess this is 12:30 at night. The spacewalks will all start at about between 9 o'clock and 10 o'clock Oklahoma time, between 10 o'clock and 11 o'clock Eastern time, because the astronauts, although the NASA schedule for their spacewalks was to be just before midnight, seemed to be enjoying getting out of the airlock and into space about an hour ahead of what the mission planners had suggested. So they'll be doing their work during the hours, as I say, your local time between 10 o'clock and about 3 o'clock in the morning. So set the VCR up for those times. That time Eastern between, I would say, 10 o'clock and 5 or 6 o'clock in the morning. I asked my wife to run a videotape on what we're doing tonight. I told her to start it at about 11 o'clock and let it run till about 6. So that's what I'd urge you to do night after night, too, as we continue our coverage. We have another caller on the line now from Georgia. Go ahead.
Hi, my question is, I understand the Hubble telescope is going to be able to have information at or near the edge of our universe. Is that in fact true? And if so, what do we think we're going to be able to see out there?
Good question. Ed Weiler alluded to that a minute ago, our local astronomers. Talk about the edge of the universe.
Well, we do hope that Hubble will extend our vision out to the edge and will even maybe tell us where that edge is. Right now, it's known that we can estimate that the edge is an edge in time at about 10 to 20 billion light years away, but by the time Hubble views the very distant objects in the solar system, we hope that we'll be able to improve the accuracy of that figure down to within an accuracy of about 10%.
It's also interesting that people say, well, will Hubble be able to see the end of the universe? Well, actually, it's more like, can you see far enough to see the beginning of the universe? Because as you look further and further out, the light reaching your telescope has left that object further and further back into time. And so the most distant kinds of objects we're looking at distances of up to maybe 14 billion light years out are objects called quasars. And quasars may hold the key to what our early universe was like. It may be the early universe was populated with these very, very luminous, small by galactic standards objects. And so the Hubble may unlock some of those keys of what the early universe was like.
Amazing concept. The picture you're seeing, by the way, in the large part of the TV screen was the astronauts at work earlier this evening as they were replacing one of the solar panels aboard the Space Telescope. Our next caller is from Illinois. Go ahead.
Hello. I was wondering if you can tell me if double star systems will be more common and will Hubble be able to locate these? And also, will the solar winds have leave any impression on the Hubble Space Telescope?
The first question about double stars, it turns out that the majority of stars in our galaxy are double or triple or more complex, maybe about 60%. The Hubble Space Telescope will be able to probably discover or resolve systems we've never seen before that have many components. As far as the solar wind goes, it won't have any detrimental effects on the Hubble, although on big solar winds you might, and I should back up and explain, solar wind is a stream of high energy particles from the sun, and when the sun is very active, the solar wind could in fact be heavier than normal, and so it might disrupt some communications from Earth to Hubble. But as far as damaging the Hubble Space Telescope, we shouldn't worry about that.
All right, our next caller is from Ohio. Go ahead, please.
Yes, I have two questions. The first one, assuming they finish everything on time today and during the 5-day plan, do they have any other repairs they might try and what those might be? And also, what percentage of the time of the telescope goes toward solar system studies like the planets or maybe comets and asteroids?
Okay, Anita, you talk about how much time the telescope looks at the planets and how much time it spends looking at the stars and other things, or you or David, either one. And I'll tell you after you've answered that part about what's in the 5-day plan if they get everything done that they expect to get done.
I think it spends about 10% of its time looking at solar system objects and about 21% looking at galaxies and clusters of stars within our own galaxy. Quasars and other active galactic nuclei take up about 20-some%. And then cool stars, just the interstellar medium structure in the universe is the remainder of the observation time.
Yeah, this repair mission for the Space Telescope was scheduled to take 12 days. And the reason NASA scheduled it for 12 days when they were only going to be walking in space 5 days was because they figured a lot of things would go wrong. And they were going to have to go out on a 6th day of spacewalk or a 7th day of spacewalk. And that could still happen. But so far, everything that they've done has been on or pretty much ahead of schedule. And if the astronauts continue to work like this, what they'll get to do the last 3 days of the mission, the astronauts aboard the Shuttle Endeavour, is look out the window. It is every astronaut's favorite thing to do. And they'll get a little free time. There's 1 day off for the crew built into the schedule because it's very difficult work to be out there trying to do these repairs in weightlessness. And so they may take a day off in the middle of the repair work, but if they get all 5 days done in 5 days, they'll have a couple of days to take off and look out the window and be astronomers on their own from a very unique vantage point. I think our next caller is from Florida. Go ahead, please.
Yeah, you mentioned earlier in the program that a comet will hit Jupiter, and I've heard some news that the comet that will hit Jupiter will make an impact on the Earth's magnetic field. Could that be possible?
As I understand the question, would the impact on Jupiter affect the magnetic field of the Earth? Is that the question?
Yeah, that's the question. Go ahead.
Okay. The impact on Jupiter is probably going to be equivalent to about 10,000 tons of TNT going off. It's not really an explosion, but it is a very large release of energy in the atmosphere of Jupiter. Jupiter's magnetosphere extends out into the around the satellites of Jupiter. Jupiter has a total of 16 satellites. But as far as the magnetic field of Jupiter affecting the magnetic field of the Earth, I don't think we'll see any effects like that here on Earth. You may see some effects on the magnetosphere of Jupiter, though. It's interesting to note that one of the things that the Hubble will be able to pick up as the comet impacts the atmosphere of Jupiter is it will be able to discern what the comet's made of through some of the spectrometers aboard the Space Telescope, be able to split the light of the object and analyze the light so to see what the comet's made of. The other interesting thing is that the impact on Jupiter is probably very, very similar to the impact of a comet or an asteroid type body that hit the Earth about 65 million years ago and caused perhaps caused the extinction of the dinosaurs.
This is an amazing story. You know, the things that we're going to be able to detect on this telescope, just amazing. We have time for one quick call from California. Go ahead, please.
Yes. When you have the space shuttle traveling at 18,000 miles an hour, and the astronauts outside in space here traveling at the same speed, why did they not separate away from the shuttle itself and happen to travel at the same speed as the shuttle? They just have jettisoned now one of the solar panels. Why don't they jettison off? What keeps them close to the...
They're physically touching it. That's one
well, no, it's the same reason that when you're cruising down the interstate in your car and you roll down the window, you don't fly out your car. because your body and the car are moving at the same speed. The reason the solar panel quickly disappeared, as you saw earlier, is that they actually fired a rocket on the shuttle to move it away from the panel. There is some drifting in space, and so if you detach the astronaut from the shuttle, something you wouldn't want to do if you wanted to stay an alive astronaut, the shuttle, you might have the astronaut drift slowly away, but it wouldn't fly away because the astronaut and the shuttle are moving at the same speed. And that comes back to a comment that was made earlier about 0G in space. That doesn't mean zero gravity. In fact, the amount of gravity on the shuttle and the amount of gravity you're feeling now in your living room watching the television is about the same. But what the difference is that the shuttle and the astronauts are falling around the Earth. So if you ever go to a local amusement park on a roller coaster and you go down the hill and you feel like you're coming out of the seat, that's the same thing that's happening to the astronauts, only it's a lot bigger roller coaster and going a lot faster, but they're falling around the Earth and they're falling at the same speed. So that's the difference between 0G and zero gravity.
We're going to take a break. We'll be right back. Stay with us. Our coverage from Endeavour and CNN will continue as the astronauts continue to fix those solar panels. We'll have some more live pictures coming up shortly. Stay with us. Hi, and welcome back. Let's look at the picture that the Johnson Space Center is sending out to the rest of the world right now. The picture on this side of their screen shows you where the shuttle is. It's off the east coast of Africa, moving down toward Australia, and it'll be back in satellite range, so we can probably see some live pictures from the astronauts pretty soon. Over here is an illustration of what is going on. The astronauts are out on the robot arm. Kathy Thornton is out there now. We just listened into some of her two-way radio conversation with the ground. She and her partner in space have got the second solar panel almost loose from the Hubble Space Telescope. After they get it loose, they will take it and put it down in the cargo bay, and then they'll put the replacement solar panel out there. The astronauts are working much more quickly than the NASA planners on the ground had expected them to. We continue to take phone calls from viewers around the country, and we have a couple of experts here to help us with those phone calls, including Anita Kern from the Fernback Science Center in Atlanta and David Dundee from there. Anita, what do you do when people say to you, why should we be spending all this money and time on space research and the Hubble Space Telescope?
Well, of course, one of the answers that I think that I have heard voiced before is that we really don't spend any money in space. It's all spent on the ground, and it's spent to employ everybody from astronauts and physicists and engineers and computer programmers right down to the person who sweeps up and all those different positions. So it is a great peacetime economy generator, but also I think it's very important because it's sort of knowledge for knowledge's sake. You can't really know at this point what might fall out of these discoveries that the Hubble Space Telescope will make.
Yeah. Plus the fact that, as Anita just said, that the economic impact of the space program shouldn't be underestimated. We're talking about, I think the figure was quoted earlier as $1.5 billion on the Hubble Space Telescope. That wasn't spent on Mars. It was spent here on Earth, employing people. Those people take their paychecks and pay taxes and support their families and their communities. The space program is one of the industries that the United States is a leader in the world. And so I don't think we should just think about money being spent into space. It's being spent here on Earth. And the other thing is that I think Ed Weiler said earlier, I don't think we should underestimate the impact on young people, the importance of astronauts being role models to young people. Very different from folks in entertainment world or in sports. The astronauts are not in it for the money. They're up there risking their lives right now in a scientific endeavor which they love. And I think it's a good role model for young people to see. And the other thing I think we should mention is all of the technical spin-offs from the space program. The list could go on longer than this telecast, from radial tires, Corel dishware, to all the hospital technology and computer technology.
Pacemakers, Teflon.
Digital watches, things,
hang gliders.
You can go on and on. And the space program's technology is spun off into our everyday lives in all sorts of ways.
All right, we got a caller from South Dakota who'd like to chat with us. Go ahead, South Dakota.
Yes, I had a question as to, I guess I have two questions. One is, what is the temperature differentium from Earth to space? Like, how cold is it up there? And then my second question is how difficult is it for the astronauts to be working on the Hubble with the bulky astronaut suits on?
Temperature's real cold out there in the cargo bay, about 200 below zero Fahrenheit, I'm told, and it's pretty difficult for the astronauts to work in the bulky spacesuits. Last night on our broadcast, we had the representative from the company that makes the spacesuits. They're trying to improve them to make them easier and easier to work, but it's like you're working inside of a blown-up balloon. The spacesuits are pressurized, and it would be like you're standing there with the pressure forcing your arms out straight from your body and your legs out straight from your body. And there are joints and attachments inside the suits to make them easier for the astronauts to use them to work. But as you watch these astronauts work, in these pictures which we took several hours ago as the first solar panel was removed from the side of the telescope, you can see the astronauts are not able to bend their arms very well at the elbows, and it's very difficult for them to move their fingers. There's special gloves that they wear to keep their fingers warm and to also allow them to move their fingers to grasp these power tools. But the power tools are much bigger than tools on Earth because the gloves are so clumsy that you couldn't pick up, for example, a fine, small screwdriver to do some of the repair work. A little bit later in the mission, they're going to be replacing some computer cables that are identical to computer cables on Earth, and that may be one of the toughest jobs they do because they're going to have to use little screwdrivers with those big gloves. Our next caller is from Ottawa. Go ahead, please.
Yeah, hi. My name's Tom Harris. I'm calling from Ottawa, Canada. I had a question that was continuing along the lines of what we were just discussing concerning the justifications for spending money on Hubble and other space projects when there's so many other concerns on the Earth right now. I've heard space critics say, and I'm not a space critic, I support the space program, but I've heard them say that many of the arguments that have to do with spin-offs or other kind of technical justifications or even inspiration to students in school could also occur with other highly visible, high-tech, exciting projects, and perhaps projects that have very strong intrinsic value, things such as cleaning up the environment or whatever. So I guess the real basic question is, does the exploration of space, and in particular trying to understand the origin of the universe through this telescope, does it have intrinsic value to us as human beings?
I'll ask our astronomers to answer
that. Well, a French philosopher once said that astronomy is useful because it's beautiful. And the study of astronomy of the sky has revealed new beauty in the universe, the violence of galaxies, the birthplace of stars, and to see that beauty of the universe of creation is an inspiration, I think, in our everyday lives to be able to see that. As far as nuts and bolts, how does it affect me? The space program has been able, from the shuttle, to view conditions here on Earth, environmental pollution problems, tracking pollution. The Hubble Space Telescope itself was not made to view the Earth. It was made to view out from the Earth. Nevertheless, understanding the circulation patterns as we're about to see them disrupted on Jupiter, I come back to my favorite topic, I guess, tonight, Comet Shoemaker-Levy. It may help us understand the weather patterns here on the Earth better, and certainly predicting weather more accurately here on Earth has profound implications for life here on Earth.
We're going to take a break. When we come back, we'll see more pictures from the Hubble Space Telescope, or at least pictures of the Hubble Space Telescope, a spacecraft that hadn't been seen by humans in 3.5 years. And it looks pretty good as the astronauts are repairing it right now. Stay with us. We'll have more in a minute. Welcome back. After about a 40-minute break from live pictures from space, we have some new ones to show you here of Kathy Thornton and Tom Akers at work out there on the second of 2 solar panels attached to the side of the Hubble Space Telescope. We haven't been able to get live pictures for the past several minutes for a couple of reasons. There are only 2 tracking and data relay satellites that are used by NASA and many other people to send pictures back to the Earth. And it looks like the picture that we had from one of them has just gone away due to some sort of interference. But because those satellites are used by people other than NASA some of the time, other users, including the United States intelligence community, use those same satellites to relay pictures from, for example, spy satellites back to Earth. There are times when we can't get our live pictures because the satellite's being used by somebody other than NASA. But this picture is certainly live. You can see Kathy Thornton and her partner Tom Akers in space there now. They're both hard at work. Thornton is on the robot arm. She's at the bottom left of your screen. Her feet are under the CNN Live sign. And Akers is up there on top of her. It appears that Thornton is holding Akers by his legs, his lower legs, while he goes up to do some work on this solar panel to remove the second of two old solar panels from the side of the Hubble Space Telescope. While we haven't had live picture, we have been able to listen in to the conversation between the astronauts and the ground. And what they have been telling us is that they haven't had a lot of problem in disconnecting the various latches that hold this solar panel onto the side of the telescope. We can listen in and see what they are saying as they do their work. Got it. Sounds pretty good.
I got you.
I just don't want that other one to come floating out of here.
One thing they can't afford to have happen is one of the bolts that they are loosening to go off into space, because they're going to need all those bolts to reattach the replacement solar panel.
Okay, it's in there. Closed up. Okay,
Story Musgrave, the payload commander, is back in the crew cabin, but he's looking out the window and looking at television as we are.
Got them both, all in one piece, in the trash bag. Okay, KT, how about me giving you back the cutters?
All right, just sweep back in there.
Okay, thank you. Good job helping me.
It'll be trustable.
I want to get a foot stable first.
No, you're not even close, huh?
Go in more.
No, you're in the middle. You're between foot legs.
Oh, I'm sorry.
I wonder if NASA planners had anticipated having Thornton grab Akers by the legs for him to do this particular repair. One of the things that we've been told is that when you're in space like this, and you are apparently weightless, if you try to turn a bolt with a normal wrench, you can't do it because your body is going to turn the opposite way of the wrench because you don't have the normal effects of gravity to keep you in place.
Really awkward here.
Well, as Tom Akers said, it's really awkward there.
Okay, just let it go.
Someone's got to get these back in the caddies. Then we'll be dang on.
All these dangling tools are attached to the astronaut spacesuit so that they don't go off into space, too.
A lot of work story for two little pieces of wire.
They're trying to pull out the two wires that supply power from the solar panel to the telescope. And as you could hear them say,
Okay, that's all cleaned up. That's all cleaned up. Okay,
they've been having some trouble, but they've cleaned it up.
It's stowing, huh? I wonder if they want me to use the... I'm going to use the airlock on the PDM. 5 2/3 turns, counterclockwise, low RPM, you can use torque 5. Yeah, I'll measure my torque.
We're going to take a break. We'll be back in a couple of minutes with more live from space, from Endeavour, and from CNN.
Or loose end. I'm going to stand by.
Welcome back to our viewers from CNN in the United States and around the world on CNN International. John Holliman watching as the Space Shuttle Endeavour astronauts continue to repair the Hubble Space Telescope. A solar panel is being replaced at this moment, the last of two to be repaired aboard the telescope tonight. Astronauts say they're a little bit ahead of schedule. They've been out in space for more than 3 hours, and they have another 3 hours that they could stay out there if need be. In fact, they could stay out longer than that, according to the managers on the ground and the manufacturers of their spacesuits. They could stay out as long as 8 hours at a time. We have a lot of viewer phone calls, a couple of expert astronomers here to ask or answer astronomical questions. Let's go ahead and go to our first caller from Oregon. Go ahead, from Oregon.
Yeah, my name is Neil, and I was calling in reference to the solar panels that were jettisoned from the Space Endeavour.
Yeah.
I was wondering what the chances were of that solar panel hitting another satellite.
Because of the orbit that the shuttle is in right now and the orbit of most satellites, the odds are not that great. Most satellites fly at an altitude much higher than 300 miles, and this solar panel is going to start falling toward the Earth pretty quickly. And it's very lightweight, and if it did hit another satellite, it would probably do more damage to the solar panel than to the satellite, my guess. Thanks for the call. Our next caller is from Connecticut. Go ahead.
Yes, I'd like to know how the Hubble points itself from one stellar object to another.
They have a catalog of about 15 million guide stars, and the gyroscopes actually move the telescope to the appropriate on commands.
Okay, next call is from Florida. Go ahead, please.
Yes, I'd like to know how long the Hubble will be being used, how many years, and if there's any plans to have anything added to it.
Yeah, the telescope is going to stay in orbit for a total of 15 years and maybe longer than that. It is possible that it could stay up longer if something better has not been invented on the ground. And so that's the answer. It's not going to come back to Earth until the end of its life. It's ground-based. NASA managers don't think they should leave it up there forever unless there's nothing better than the Hubble Space Telescope to go up and replace it. But it's hoped that in the 15-year life that they've scheduled for it, it'll be able to provide as much science coverage as any telescope in space has ever been able to do. Our next caller is in Florida. Go ahead, please. I'm sorry, Pennsylvania. Go ahead in Pennsylvania.
Oh, thanks. What's the chance of them getting hit by a piece of high-speed space debris? And second question, last night you could see a glove floating around off the tool stand. Is that an emergency glove for cutting, if they cut them, so, open a hole, or any idea?
Let's see. It's not an emergency glove. It's just an extra glove in case their hands got cold. Ask the first part of your question again, Pennsylvania. Do you remember
Yeah, it was about what was the chances of being hit by something. Very, very small. There is debris in space, bits and pieces, micrometeorites and so on, but the chances of being hit by a micrometeorite in orbit is about as great as being hit by a meteorite here on the ground. I wouldn't run out and get an insurance policy. You're pretty safe.
All right, our next caller is from Indiana. Go ahead, please.
Hi, my name is Nancy, and first of all, I just think it's fabulous that you're showing all of this. And my question is for your astronomers, if they could tell me how much the Hubble telescope will be able to give us information about physical properties in the universe, such as dark matter, or shed light on things like string theory.
Well, they do hope that the Hubble will be able to shed some light on the issue of black holes. There's a lot of matter in the universe, and based on the amount of matter that we can see, it's not enough to stop the present expansion. And a lot of people theorize that there's a lot of missing matter out there, maybe in black holes that we don't see. And if they find black holes at the centers of these active galaxies and quasars, then that may be some evidence that there's a lot more matter than we ever realized. And that may be enough matter to halt the expansion of the universe or even cause it to collapse back.
I also want to add to that the Hubble Space Telescope is one of several satellites that are in orbit and planned looking at various wavelengths of the spectrum. And so this is part of an armada of spacecraft looking at various parts of the spectrum to analyze what's going on out there. This one, along with another spacecraft called COBE, that has looked for very small temperature variations, like we were talking about, possible answers of where the universe is going and where it's been.
What a picture. What a picture. Let's listen in for a minute.
Kathy Thornton, who is on the end of the robot arm up near the top of the telescope. And Jerry, we were just discussing here in the room the reasons for actually having to put this solar array back in the stowed position completely. There may be some questions as to why you can't just remove it and save the time before you go ahead and put the new array on.
Anita brought the pen with her. And put it
Right, Kyle. The problem is that the solar array carrier that they'll have to put this old solar array back onto to bring it home requires that the solar array be in the configuration that they're now driving it to, so that it can be mounted safely to bring it home.
First time I see 15. That makes sense. Yeah, that's
We still have lots of callers backed up on our phone lines, and we'd like to get to as many of you as possible. Next caller is from Ottawa.
Is this me?
Yep, you're on. Go ahead.
Oh, thank you. First of all, congratulations to all of you. Incredible pictures.
I'll say.
Two questions. One, scientific. Given the tremendous advance of science and the pace of it on Earth, is it possible that they would go back up to uprate the Hubble? That's the first question. Second question is humanistic. Those guys are out there for 6 to 8 hours. We know the suits are very cumbersome, but what about other problems they might run into of a human nature?
The suits are available to help you if you have to urinate. The astronauts all wear a device. Well, there are two things they can wear. There's an actual diaper that comes with the spacesuit, and there is another collection device that some of the astronauts could adapt to their bodies. And as far as other physical problems, they have to wait till they get back inside. But you know, that was taken into consideration. So that's the humanistic question. I'll let my astronomer buddies talk to you about the other one. Upgrading the Hubble, it's certainly designed to be upgraded.
There are scheduled servicing missions roughly every 3 years scheduled for the Hubble, and I would imagine as technology advances and computer technology advances, there'll be some changes. And also the Hubble's available to change. You can change out experiments. You might want to change out.
Even right now, the wide field planetary camera that will be exchanged tomorrow night, the new one has much better CCD imaging and is much upgraded, and because it won't even have to use the CoStar because they're replacing that instrument, they actually built corrective optics into the camera.
Let me tell you what's going on in space before we take a quick break. The solar array, which was sticking out perpendicular to the telescope, has now been folded up against the side of it so that it will fit more easily into a container out on the cargo bay of the shuttle. We're going to take a break. We'll be right back and hopefully be able to show you some more beautiful pictures of our planet and this telescope in orbit. Hello and welcome back. Live picture from the Space Shuttle Endeavour, the Hubble Space Telescope. Let me get out of the way and let you look. The telescope in sunlight as it passes over Australia and the Pacific Ocean. It'll be coming up to the west coast of the United States fairly soon. The astronauts on board have replaced one solar panel already. This is the second solar panel, which will be removed. The astronauts are working very, very slowly because they don't want to damage anything else on the telescope as they do their work to replace these parts. But NASA has created a speeded up, animated version of the repair and replacement mission of these solar panels, so we can show you sort of what's going on through the eyes of the NASA animators. New solar panel there coming out of its spot on the cargo bay. Astronaut Kathy Thornton would take it up to the side of the telescope, as she will do in a few minutes, and plug it into the side. And then the astronauts will use this power tool to screw the latches into place and make sure that it's mounted firmly to the side of the telescope. The astronauts will both work in this manner that you see here to do that job. So that's what's going on, but it's happening much more slowly than that animation that we just showed you there provided. You can see one of the telescope's high-gain antennas there on the right of your screen as you see the curvature of the Earth down through the bottom part of that antenna. That antenna and one identical to it on the other side of the telescope is how we get the pictures from the telescope back to the Earth.
Okay. K-Town, continue the retraction right into the latches. Okay, Thor, will do. Okay, KT, go ahead. When you get it in, I'll hold it and you can drop down to the handle. Okay, that's good. Okay, you in there? Okay, I'm showing stowed.
Hey, it's in the forward latch.
Okay, I'll hold it and you drop down to the handle.
Okay, I believe astronaut Kathy Thornton is at the top of our screen, and Tom Akers is not visible right now, but I'm not going to swear to you to that. I won't stake my reputation to that. Thornton has stripes on her spacesuit.
So keep coming back, then I'm going to go to MFI 0, and then you can take me to the position to take it off. You might come back another 3 or 4 feet. Well clear.
Yep, that's Thornton because she's on the end of the robot arm, which is moving right now.
Yeah.
Our next caller is from Georgia. What's your question?
Yes, I'd like to know, I understand that the shuttle's now at about 350 miles out and traveling at about 18,000 miles an hour. I was wondering if you could help me understand where in relationship to the geosynchronous orbit they are and the different speeds that things go around the Earth at different distances.
astronomics, I suppose. The shuttle is traveling at a speed of 17,000 miles an hour, which is the speed that it needs to travel to maintain an orbit above the Earth. It is about, as you suggested, about 330 miles up. And if the speed were to slow down as much as 200 miles an hour, the shuttle would 1 hour later be down on planet Earth. In fact, the astronauts fire rockets on the shuttle to slow it down when they're ready to get it to come back home. As far as the geosynchronous orbit is concerned, the communication satellites that have been launched to provide you your CNN right now, for example, are in a different orbit that is geosynchronous. They rotate at the same speed as the Earth. So when the Earth moves, they move at exactly the same speed, so they don't appear to move in relationship to the Earth. And that's how communication satellites work. They're not traveling at any speed at all relative to the Earth, whereas the shuttle is traveling at a speed of, as I say, about 17,500 miles an hour to do what it does. Our next call is from Virginia. Go ahead, please. I'm sorry, do we have another caller now? Saskatchewan caller. Go ahead.
Yeah, I was wondering, I have a question for the astronomers.
Yeah.
If SETI receives any radio transmissions of such significance, would the Hubble telescope be able to pinpoint such origin of transmission?
Well, seeing planets is real tough because planets, number one, are tiny compared to stars. Number two, planets don't give off their own light, so they're very difficult to image in other solar systems. And so if a radio telescope picked up an intelligent hello from somewhere out there within our galaxy, we might be able to pinpoint with the Hubble the star near the planet that this civilization might be going around. But seeing the planet itself, that would be quite a trick.
We don't really have anything in the inventory on Earth that would allow us to see sources of extraterrestrial life unless those sources of life came right down into our solar system, right?
But the Arecibo radio telescope has picked up accretion disks around stars. These are disks of dust and matter that and objects that are either very large planets or small brown dwarf stars, and it's just unclear as to which they are.
Yeah, okay, we're going to take a break. We'll be right back as the astronauts continue their mission to repair and replace 2 Hubble Space Telescope solar panels. They're happy. Live from 330 miles above the Earth, 2 NASA astronauts are out on a spacewalk to repair the Hubble Space Telescope. Let's listen into what they're doing as they're preparing to move the second of 2 solar panels away from the telescope. Tom Akers is using a power tool and radioing to the ground each time that tool turns.
Over on the right.
He's going through the process of unscrewing some latches that are connected to that solar panel. When they're all loose, the panel will come away from the telescope. While we wait for that to happen, we hope we'll be able to see it live. We'll go to our next caller in Alberta. Go ahead. Well, so much for that. We have another caller lined up here. Okay, we have a caller from Maine on the line. Go ahead.
Yeah, 4 quick questions. First of all, congratulations on the great coverage. First question is the panel storage, the one they had to throw off. Why could it not be stored in the cargo?
2 crew members approaching.
Okay, the answer to that is that it has to be rolled up in order to physically fit inside the cargo bay, and they couldn't roll it up.
Okay.
There was a kink in one of the support rods that just wouldn't go back into this cassette out in the middle of the solar panel.
Second question, we were watching and he was putting the nuts and bolts and screws and so on into a bag. Do they have spares with them? So in case they happen to lose that one, would they have the right pieces?
Yeah, you bet they would. The real concern about putting them in the bag is they don't want anything loose in space around the telescope, because if some tiny screw got inside the optical system of the telescope, it could really mess it up forever. So they have this the garbage bag to keep things from being loose in space. But yes, they do have spares.
And if you get time during the broadcast tonight, I stayed with you as late as I could last night, but I never did see the end of what they finally did to fix the closing of the doors around the gyros. And my last question would be for the people you have with you, a quick explanation of what a black hole is, please.
Okay, before we get to the black hole explanation, let me explain to you what they did to fix the doors last night. They put a belt around two handles on the outsides of the doors, tightened that belt so the doors were forced shut, and then they were able to get the 4 latches outside to close. What are black holes?
Oh, black holes are actually, in the stellar evolution process, we have stars of various masses, and if a star exceeds 3 times the mass of our sun, when it exhausts its nuclear fuels, it will begin to collapse because there's no radiation pressure to hold the gases out there. If it's so massive that it collapses to a point where it gets to be very, very dense matter, and the escape velocity to leave this gravitational well is greater than the escape velocity for light, and so even light cannot escape. And what we actually see when matter gets drawn towards the black hole is we see the matter accelerating, and it sheds energy and is heated thermally and begins to glow. But once it passes the event horizon of the black hole, it's gone and will not be back.
All right, thanks very much. Okay, we have a call from Ottawa. Go ahead.
Yes, hello, John. I was wondering if Hubble was going to be used to search for places of future habitation of mankind, and if so, what might those places be?
That would be probably a no. The Hubble Space Telescope can look at other stars, sun-like stars, and we can find them. But as far as locating planets, again, that would be difficult. There are some clues, like the accretion disks that Anita mentioned earlier. But those are solar systems in formation. You want to look for solar systems that are already formed. So you could look for stars that are turning more slowly because they've given up some of their turning energy, their angular momentum, to perhaps a planetary system. But that would be difficult to do with the Hubble Space Telescope. It could look at Mars. Mars might be a future place where man could set up colonies. But as far as a planet like the Earth, it'd be difficult to find with Hubble.
Our next caller is from California. Go ahead with your question, please.
Hi, this is Dave Ramsperger in Yorba Linda, California. I'm curious how long they expect it to take for the checkout of the Hubble after the CoStar system has been installed to verify that it really did correct the problem.
We had Ed Weiler, the program scientist from NASA, on about an hour ago, and he said 6 to 7 weeks. The lenses on the CoStar device will be, or the mirrors will be lowered into place within a couple of days, and after they're in place, they'll begin, there'll be some scientific work done inside the telescope even before the large aperture door at the end is opened again, but it'll probably be 6 to 7 weeks before we see pictures. Ed Weiler said we'd get first dibs of the pictures here at CNN when they come up, so we'll look forward to showing them to you. We're going to take a break. We'll be right back. Welcome back to our live coverage of the mission of Space Shuttle Endeavour to repair the Hubble Space Telescope. I'm John Holliman. Right now you can see over my shoulder a picture of Mission Control in Houston. The reason we're looking at Houston is because we can't see the telescope right now. And one offshoot of that is that we can't tell precisely how well the astronauts are doing at replacing the second of the 2 solar panels aboard the Space Telescope. But the last time we did see them, they were very close to having the first panel ready to remove, and it appears that they're going to be able to get the second panel off the Space Telescope just about on time, as they had planned to do. They have another couple of hours that they can stay out in space and do this job, and they're a little bit ahead of schedule. We have one caller left who'd like to ask a question from Georgia. Go ahead, Georgia. You're on the air.
Yes. Recently, there was a comment made that there was no problem with impacts from meteorites, but I know that 200 miles above the surface of the Earth, you don't have the protection of the atmosphere from the burnout of meteorites that we see when we look up at a shower. In fact, I think a recent shuttle mission had a problem with a speck of paint hitting the windshield. And I also wonder, can that not only happen to the telescope, but will anyone visually inspect the mirrors to see if that has happened?
nobody will visually inspect the mirrors to see if that has happened, but the whole design of the Hubble Space Telescope is to protect that mirror. Any fleck of paint or anything of space debris that would go down the barrel of the telescope would have to go through a series of baffles, and it would have a tough job to get down and hurt the mirror. That's one of the things in the design of the telescope that was done to protect it. We have, and the NASA managers on the ground have, conducted a visual inspection of the telescope. They've gone over it inch by inch since the Endeavour has been there for the past 3 days, and they have found no visible damage that they have cared to report to us. It's fairly miraculous, I suppose, that there has been no more damage. The astronauts themselves, their spacesuits are in excellent shape. They've been outdoors for 8 hours last night and about 6 hours or 5 hours so far tonight, and there have been no real problems with this. We're going to take another break. We still don't have live pictures from space. What we do have is CNN Sports Late Night, which is coming up to bring you up to date on everything that's been happening in sports down here on planet Earth. When we come back at the top of the hour, we're going to have more pictures from space to show you how the repair mission of the Hubble Space Telescope is coming on this second night of spacewalks. Stay with CNN. We'll keep you posted on whatever is happening down here or up there.
Electronics, those are primarily small tasks.
Two spacewalking astronauts have completed attaching the second solar panel to the side of the space shuttle, rather the Hubble Space Telescope. What they have to do next is to plug in the electrical wires that go from the solar panel to the batteries inside the space telescope. They're doing that now. They've been outside now for a total of 5 hours and 30 seconds, and they're going to get to stay outside a little bit longer and do some additional work, we are told. The answer to the question of what's the name of the fourth space shuttle that I couldn't remember before the break is Atlantis. So the four are Columbia, Endeavour, Discovery, and Atlantis. And the people at NASA tell us there's a formula for determining the orbit of the Hubble Space Telescope, and they are furiously looking for that formula as we speak. Our next caller is from British Columbia. Go ahead, please. You're on the air.
Yes, another caller already asked a similar question to mine, so maybe you'll get an answer later to how high they would like to have the Hubble flying. But the other two parts were, what's the angular pointing accuracy of the telescope in fractions of a degree? And the last thing was, I don't think someone got it right about, why the astronauts and the telescope don't fall towards the Earth. It's the balance of gravity and the Newton's second law. If there was no atmosphere, they would circle forever. I've got a background in orbital mechanics, and that's the same reason the moon doesn't fall out of the sky. Did you get any answers on those other two?
Okay, how high they'd like to have the telescope in space? They'd like to have it almost where it is, maybe a little bit higher than where it is right now. When the astronauts grabbed the telescope, it was at an altitude of about 320 miles. And what they are going to attempt to do on the last day before they release the telescope from the space shuttle is to increase its orbit, if they have enough fuel, and they think they will have, by about 6 to 7 miles. Having it 6 to 7 miles higher than it is will guarantee that it stays well into a good orbit, so that they won't have to worry about it until they come and do the next servicing mission, which could be as many as 5 years from now. So I think that's the answer to that question. And you may well be right about your orbital mechanics question about the objects without atmosphere staying in space forever. And as you say, the moon continues to orbit the Earth and doesn't fall into the Earth. And one of the things that the astronauts have to do to get the shuttle to come back to Earth is to fire rockets to lower its speed so that it will come back. An earlier viewer also asked a question about the solar panel and why the solar panel that was jettisoned doesn't stay right beside at the same altitude as the shuttle and the space telescope. When Kathy Thornton let it go over the side, the action of letting it go over the side slowed its speed, and the fact that its speed is now slower than that of the telescope and the shuttle will force it down into the atmosphere eventually.
Just two things. The pointing accuracy of the space telescope is to within 0.01 arc second, and the moon's orbit is not stable. In about 5 or 6 billion years, its gravitational interaction with the Earth will cause it to spiral in and break up. The fact that the the lack of atmosphere, whether the atmosphere is there or not, is of course will affect the orbit, but the fact that the gravity of the Earth does rob some of the energy of the momentum of the object going around the Earth. And the same thing happens to planets too, in their speed around the sun.
All right.
That's changing too.
Okay, our next caller is from Illinois. Go ahead, please.
Yes, my name is Mark Narink. I'm calling from Morton, Illinois. My question is for all three of you, basically. If money were no object, and it was your choice, and you were picked to go on the shuttle itself, what would be the ideal mission for Mr. Holliman as a journalist, and what would be an ideal mission for both of the astronomers?
For me, Earth observation would be the ideal mission. I'm negotiating with NASA and have been for some years to be the journalist on the space shuttle. And if I succeed in this negotiation, I'm going to, I hope, be able to provide for you a live commentary for the first 8 minutes of a shuttle flight. It seems to me that would be remarkable television, to be able to describe as it happens what it's like to lift off the pad and make it into orbit. And that's my pitch. NASA has so far failed to accept it. They don't like the idea of civilians in the shuttle because of the public fallout after the Challenger disaster when they had a teacher in space and a civilian on board the shuttle. But I'm working on it. It may happen. It may come true for us. And once I got up into orbit, I would just, I would sort of do like I did in Baghdad the first night of the Gulf War, keep my head in the window and tell you what I could see as frequently as they would let me. How about you astronomers?
Well, I think my interests turn toward classics, and if I like archaeology, and if I had the opportunity to point the Hubble anywhere, I would like to study the most distant things that we could see because they're the oldest things in the universe, and it's like cosmic archaeology. And we've already, with Hubble, seen some evidence of young globulars, which is sort of like finding Jurassic Park out in space.
I think for me, I would just like to peer out the window, even though with all the fancy equipment and looking at galaxies and so on, just to be able to see your own planet Earth down there would be an incredible experience.
I think all of us probably relate to the astronauts when they say that's the most fun they have on orbit, looking out the window. NASA says that one orbit of the telescope is 23,524 miles. Our next caller is from Nevada.
Yes, sir. I'm in the military. I'm enlisted. It's kind of along the same subject. As far as enlisted people or NCOs, when, in your opinion, would you see people like that going into space?
I'm not sure. I think the people who are in the astronaut corps are the only ones from the United States who are going to be going into space for the next year or two. But I take hope in the fact that Story Musgrave, the payload commander, is 58 years old. That's a lot older than I am. And if I can get in decent physical shape, you know, perhaps there'll be a chance for me. Let me interrupt for just a second to point out that we've got our first live pictures from Endeavour for several minutes. And these are pictures showing the robot arm. If you look on the right-hand side of your screen, out at the end of the robot arm, you can see astronaut Kathy Thornton, who is out on the side of the Space Telescope doing some of the final work to attachment of the second replaced solar panel to the telescope. We're going to listen in and hear the commentary between the ground and space for a few minutes.
Okay, KT. Coming in.
Craig's here. He's coming, folks. I'm watching. Over a little bit more. You're going to be okay. A little bit more. A little bit more. Okay, it's good for Ed. If you can take a report about 6 or 8 inches.
Okay, could you give me eye calibration on how far the stanchion is from the array?
Maybe from the picture frame, probably 2.5 feet.
Oh, okay. It looks a lot closer. It's like 8.
Yeah, I bet it does. Come forward.
You can see the telescope there on the right, the shiny object, and the Earth back behind spinning slowly. Our next caller is from Georgia. Go ahead.
Good morning, John. Mike Miller from Fort Valley.
Hi, Mike.
We've talked about this being a $3 billion project. That's about, I'm figuring this in my head, but about $12 for each man, woman, and child in America.
Yeah,
I'd
about
like to
50
ask the
cents a year.
scientist, how will each man, woman, and child in America get $12 worth of value?
Did you hear the question? How will each of us get $12 worth out of this telescope? Anita.
Every individual may not get $12 worth of value, but I think we do see, we can't really predict what the benefits from the space program and the Hubble telescope will be. It's like when Columbus set out on his voyage of discovery. He didn't really know he would find the New World, so I hope that answers your question more or less.
All right, our next caller is from Kansas. Go ahead.
All right, can the Hubble telescope detect intelligent life?
I guess if intelligent life were close enough to it, it could detect it.
Only if it had a very large billboard and said, "Here we are."
The thing is, the telescope is not able to see things on distant planets. If there were intelligent life on Mars, the telescope might be able to detect it if it had a large billboard, perhaps. Our next caller is from California. Go ahead.
Hi, I got two questions. One, whenever we deploy the telescope, what keeps it from falling back down to Earth, let's say like the Skylab did? And the second question is, what does the sun look like from space? How does it look different than what we see it on Earth?
It'd be nice to know that. The telescope can't look at the sun because it would mess up all the optics inside of it. I'm trying to remember the first part of the question.
The space telescope doesn't fall down from its orbit because there are the orbit when it begins to decay, it can be captured by the shuttle and boosted back up to higher orbits like it's about to do. So the periodic servicing missions serve not only to look at equipment, but also to reestablish any decay in the orbit.
Okay, I think we have another caller on the line now. Let's see. From Georgia, go ahead. Do we have a caller from Georgia?
Guess not.
And CNN will continue with its live coverage from the Space Shuttle. We will be right back right after this. Stay tuned. Let's rejoin now the coverage with John Holliman.
In front of me. David, I'll tell you that the telescope uses the two high-gain antennas, including the one that you can see there on the right above the word NASA, to do its transmission. It transmits its pictures not directly to the Earth, but it uses a special series of satellites, the same satellites that we are using to get these pictures out of space, the tracking and data relay satellites. And those satellites are designed to transmit pictures to the Earth in a not a frequency band particularly, but in a band of space where they can't be intercepted by people other than the U.S. government, which has specific receivers for those satellites. So if you're thinking, can you sit at home with your satellite dish and get these pictures, I've suggested that you can't. Let's listen as Kyle Herring tells us how things are going up in space right now.
Bolts, tightening the last bolts on the solar array.
The torque.
That's not bad. I just can't turn the motion.
Okay.
So easy.
Three turns. Coming down good and straight and smooth. Starting to compress spring.
Once the completion is, once the solar arrays have been installed, then this task is completed. The crew is, if time permits, will prepare ahead of time for some of the other tasks scheduled for the remaining 3 spacewalks.
Hey there.
Hey, let's do it.
Okay.
There it is.
Okay. Torque limiter prompt. Okay. We'll get Zulu next.
Replacing the last solar array aboard the Hubble Space Telescope. The job is complete, and the astronauts will be getting ready for tomorrow's spacewalk now and staying outside as long as they can.
Primarily
live
these
coverage
additional
will continue
tasks
in about 15 minutes, but next, CNN Newsroom, and we'll have a report there as well. Stay with us.
This is a special edition of CNN Newsroom. As of right now, more than 300 miles above the Earth, the Space Shuttle Endeavour is orbiting on its mission to repair the damaged Hubble Space Telescope. It is an expensive mission.
That's right, Cassandra. Over $600 million, and so far it's been a success for NASA, the National Aeronautics and Space Administration right here in the United States.
Mission Control Houston, PDRS officer.
3.5 years ago, the Hubble Space Telescope was launched to high hopes at a cost of $3 billion. But soon afterwards, NASA discovered the telescope's prime mirror had the wrong shape to focus correctly.
Then there were problems with the solar panels that convert sunlight to electricity for the scientific instruments inside the Space Observatory. The panels shook as many as 32 times a day, every time the Hubble crossed from sunlight into darkness because of the sudden temperature change of as much as 200 degrees.
Overall, the Space Shuttle astronauts are installing 11 parts on the telescope during this mission. In the first spacewalk over the weekend, astronauts Jeffrey Hoffman and Story Musgrave spent nearly 8 hours in the open cargo bay. When they finished, the Space Telescope had 6 working gyroscopes, again to guide it, 3 electronics units to run the gyroscopes, and a new set of 8 fuses. NASA called the first spacewalk a huge success.
Now joining us early this morning to talk about Spacewalk number 2 is CNN's John Holliman. John?
Cassandra, the mission is going very, very well right now. You can see the live picture from space over my shoulder. We can look at that as I tell you what's happened in the 5 hours of the second spacewalk. The astronauts had to remove from the side of the Hubble Space Telescope a busted solar panel that they couldn't retract and bring home aboard the shuttle as they'd hoped they'd be able to. So they tossed it over the side. Astronaut Kathy Thornton got out on the end of the robot arm and pushed it out into space. Then they fired the shuttle's engines to move the shuttle and the telescope away from it, and it floated off into space, looking, in the words of Kathy Thornton, sort of like a bird flapping out of sight. Then that solar panel was replaced with a brand new and improved one. Right now, the picture that you see is the astronauts finishing their work, attaching the second replacement solar panel to the side of the Hubble Space Telescope. A little bit later, those solar panels will be unfurled and tested to make sure they can generate the 28 volts of electricity, which is needed to operate the telescope in space and recharge its batteries so that the batteries will keep it going when it's in periods of darkness. As you can see, it's a beautiful day in space, and you can see planet Earth rotating there behind the Space Telescope.
Well, John, we are joined by David Dundee, an astronomer with the Fernbank Science Center here in the Atlanta area. When they get this thing fixed, what are they going to be able to see with it?
Hubble Space Telescope will be able to tell us things about explosions in galaxies, locations of black holes, structures of quasars, very distant objects, keep track of changes in the atmosphere on Jupiter as a comet slowly cascades into the atmosphere over the next few months. I'll be able to keep track of volcanoes erupting on Io. Basically an eye on the universe.
Now, David, it's supposed to see billions of light years away. Can you explain that concept to us?
Sure. The Space Telescope basically is a sensitive instrument. It gathers up light looking for faint objects, and the fainter the objects you can see usually tells you can see things further and further away. Quasars happen to be, as I mentioned earlier, very distant objects, also be very bright objects. And so these objects are about 15 billion light years away.
Now, this is one of several eyes, I guess, we have up there right now, correct?
Yeah, there are several kinds of missions going on now. There's a Galileo spacecraft on its way to Jupiter, the Magellan spacecraft. It's in orbit around Venus. There are other spacecraft that are looking at different wavelengths of light to analyze different kinds of light that are coming in to different objects. And a good place for the public to learn about things like the Space Telescope would be in their local planetarium. Here in Atlanta, the Fernbank Planetarium is going to be running a show on the Hubble Space Telescope this coming summer. So a lot of this information we're getting right now and up until through the spring will be presented in that show.
Now, David, some people think the telescope is broken, but they have gotten some beautiful pictures.
Yeah, the idea that the telescope is blind and broken and the mirror doesn't focus anything is a bit overblown. The fact is that NASA scientists have been able to process the image so that it's 80% operational. And during the 3 years it's been in orbit, it's discovered incredible things, from storms on Saturn, very clear, beautiful images, to incredible images of the structure of the nuclei, this very center of active galaxies.
Now, looking at the live pictures now, why can't we see stars?
The reason you can't see stars are 2 reasons. One, the Earth reflects sunlight very well, the clouds and the oceans, and so it's very bright. It's kind of like why you can't see stars very well in the middle of a downtown metropolitan area, all the bright lights of the city. But if you could point your camera away from the reflecting light off the Space Shuttle and the Earth, you might be able to see some stars.
Okay, David Dundee, astronomer at Fernbank Science Center. Thanks for being with us on Newsroom.
My pleasure.
We now have live television from Endeavour's lower deck. This view showing mission specialist Tom Akers putting on the bottom half of his spacesuit. During this spacewalk, Akers and Thornton can be told apart from a distance in the television scenes.
Endeavour, we've got your live downlink.
They can be told apart by the markings on the legs of their spacesuits. Thornton will have a broken red stripe around the legs of her suit, while Akers will have a diagonally broken red stripe around the legs of his suit. This view now shows Thornton in the airlock. She continues donning the suit and putting on the communications cap, sometimes referred to as a Snoopy cap, which holds the receivers and microphones used for communications during the spacewalk.
Got 180 inch on the MFR today, KT, but that's all we ought to need. I have the other one with me. Oh, good. I thought I put it somewhere. Couldn't remember. That's pretty good, Claude. Okay, stay here. Houston, we will have responded to PID commentary unless you want us to.
This television shows Thornton at the array to be jettisoned.
Okay, this throws me a lot higher here, Story, than in the water. I think it's going to be all right. Okay, sensor handle is in. Antenna for it. I'm going to get the Velcro strap on the left, Story, since I'm here. And if I've got to go, it's say to slew and KT. You doing that? No, I'm not touching it. Okay, let me get it stabilized. You got the handle in it? No, the handle in it, I'll hold it. Okay, hold it still. Slew it. Okay? Yeah, I have it. Okay. Okay. On my mark. Okay, wait a second. Okay. Let's do this with your hands and not the arm, right? I will do that. Okay? Then you give Claude a command when to go, okay? I'll do that. Okay. Good, Roger. Coming out. Okay, it's easing out. It's coming real smooth. You're 4 inches out, 6 inches, 8 inches. Okay, I'd be happy for you to go with the arm now. Okay, you're forward. Out. Okay, forward. Move your forward. Slowly. Go real easy. Make sure you're not hung on my PFR. And you're not. You're clear, right? Okay, KT, I'm letting go. I have it. You have it. Holy moly. Where's the cake? Okay, just keep going forward, Claude. Steady rate. You're all clear. Okay, you're passing me right now. It looks like flying in a T-38 and looking down at lights on the ground at the stars, doesn't it, KT? You want to film over there? You ready? Yeah, I'm ready. Okay, they say you got to go for release. Expect 20 pulses on the RHT. Hey, no hands. And there's going to be 20 pulses on the RHT for a set burn. Okay. Look how stable you left that. There it goes.
Endeavour, check free drift.
Almost like a bird, Tom. Look at it. If I can still see it. There it goes. Right behind us. Okay, KT.
Ready?
I'm a hold of this end. You got that. Just come right up easy, just like you're going. Okay, bring the forward up a little more. Okay, coming straight on up. Looking real good. I'm going to let go.
Hey, Carl, it took me away.
You have it, okay? Okay, story. Leave my Essex wrench here where I need it next. Okay, Story, it's all seated. The SATA alignment key is obviously in place. Okay, looks like it's ready to tighten the SATA clamp. Double check my tool. On 1, on the power tool, torque on 2, tighten and low speed. Correct? Okay, I'm going to have to touch it a little bit, KT. You can see that side over there, right, of the SATA? All right, looks good to me. There we go. Out of the deal, my bayonet's closed. So I can get my mini workstation lower. Okay, now KT, you still got me?
I got you.
Okay. Very slowly and smoothly. I can see it coming up a little, Store. Okay. Actually, when I crank a little on it, it floats up on its own. It's floating up, Story. You see that? Yeah. I just kind of barely started moving and it keeps going.
I wanted to get there before it does.
I mean, you can just take it in, KT. Real slow. Go slow. I'll keep bringing you aft.
Can you go up a little bit, Carl? Yeah, and keep coming aft. Okay. Move toward the array a little bit, port. That's it. And keep coming in slow. Really good.
Okay, let's hold it right there, KT.
Okay, we'll stop here, Carl.
Very good.
Have you got any uplift? Can you take me up just a little?
It's hot for me because the arm's very stretched now.
Okay. How about a little bit to port? Like 6 inches.
I can give you a port.
Okay. Hey, I'm tethered to the handle store.
In the picture, you're back in here. Okay. It's seated all the way down. Don't have to hold down on it. Nice and easy. Go ahead, Greg. Go ahead, Greg.
Tom, just want to let you know that Jerry Ross and the rest of us send our congratulations to you for now being the record holder for the most EVA time in the shuttle program.
Well, Tom, thanks a lot, but I bet it's going to be a short-lived one.
Well, you get it overnight anyways, huh?
You got it. All right, let's see if we can get this bad boy Velcro back in this hole.
Endeavour Houston, some good news for you. We had a good aliveness test.
Oh, great. All right. Outstanding.
Well, there they are. And we're with you on the flight deck.
We just wanted to say hi to everybody.
Well, you look no worse for the wear from your EVA, huh?
The space repair mission is off to a bright start. Good news that NASA badly needs against the headlines about a big fraud investigation and an FBI sting.
I'm very, very sad that this would happen at this time, that someone saw fit to release that story.
Do you think the FBI should have waited?
I don't know that the FBI released it. I don't know that the FBI released it. I don't know who released it.
At the Johnson Space Center in Houston, officials say they first heard just 2 weeks ago about the FBI sting. Agents made a small phony copy of a kidney stone smasher. Working out of this Houston building, they tried to bribe some NASA employees and contractors to get it aboard a shuttle. No one has been arrested, but a half dozen NASA employees and 24 contractors have been implicated. The sting comes after other NASA failures. Maryland Senator Barbara Mikulski chairs the Appropriations Subcommittee that oversees NASA.
They have a tremendous pattern of overpromising technology, underestimating cost, and then running into technical difficulty.
NASA Administrator Golden answers that the organization simply cannot be perfect. It must take chances.
If America says, NASA, I want you to assure us that everything you do is successful, we will do that, but do we deserve to exist?
Unfortunately, because NASA is presently managed, is very decentralized, it's uniquely vulnerable to white-collar criminals coming in and stealing the taxpayers' money.
NASA's Inspector General says there are 400 fraud investigations underway within the space agency.
If they're not successful in reorganizing themselves to prevent corruption and abuse, and if the Hubble mission is not successful, I think we're going to have a very rough time with Congress next year.
A lot has been made of how NASA's future rides with that shuttle repair crew. NASA's future may also depend on fixing things back home. Jed Duval for CNN, Washington.
Die Endeavour-Astronauten setzten am Morgen die Reparaturarbeiten am Hubble-Teleskop fort. Das Riesenfernrohr soll unter anderem ein neues Solarpaddel erhalten. Beim ersten 8-stündigen Ausstieg gelang es den Astronauten, das Teleskop mit neuen Geräten auszustatten, mit denen Hubble astronomische Objekte anvisieren kann.
We got your downlink video, Jeff.
Erst einmal gab's Geburtstagsgrüße von oben. Astronaut Jeff Hoffman grüßt Ehefrau Barbara und dann sind seine Kollegen dran. Die schweren, 12 Meter langen Sonnensegel müssen Astronautin Kathy Thornton und Astronaut Tom Akers auswechseln. Auf Erden bräuchten sie dafür einen Kran. Hier oben erledigt die fehlende Schwerkraft. Das erste mit Solarzellen besetzte Segel lässt sich anstandslos einrollen und in der Raumfähre verstauen. Das zweite aber ist dafür zu sehr verbogen. Nach Absprache mit der Bodenstation in Houston lässt Kathy Thornton das Segel einfach los. Als Weltraummüll wird es nun um die Erde kreisen, bis es eines Tages verglüht.
Crew has hit 2 home runs, and that's fantastic.
Kathy Thornton, standing on the end of the robot arm, released a malfunctioning solar panel into space.
Okay, they say you got to go for release. Expect 20 pulses on your IC. Hey, no hands.
As the shuttle moved out of the way, the solar panel began to roll over the Earth. It's going to join more than 6,000 other pieces of space junk that will be monitored by the government. NASA predicts it'll orbit for about a year before being burned up in the atmosphere.
Looks like a bird, Tom. Look at it.
Thornton and her spacewalking partner Tom Akers were able to attach a replacement solar panel within an hour. Then the telescope was turned so they could store the second old solar panel and replace it. Hubble's old solar panel shook every time the telescope passed into or out of sunlight, and NASA managers determined improved panels will allow the Hubble to take many more quality pictures each day. The team of Thornton and Akers seems pretty pleased.
Well, you look no worse for the wear from your EVA, huh? You all make it look it easy.
So far, spacewalking astronauts have replaced faulty gyroscopes and fuses and have left the telescope ready for Monday night's attempt to replace the wide-field planetary camera. It's responsible for half the telescope's observations of the heavens. John Holliman, CNN reporting.
Weltraumteleskop Hubble hat ein neues Solarsystem. 2 Astronauten der Raumfähre Endeavour ersetzten in 7-stündiger Arbeit ein Sonnensegel. Die Astronautin Karen Thornton war während der Reparatur am Ende eines Roboterarms festgebunden. Das Sonnenpaddel, das Hubble mit Strom versorgt, musste ausgetauscht werden, da es verbogen war. Deshalb funktionierte das Teleskop nicht wie geplant. Das Sonnensegel wird nun ein Jahr als Weltraumschrott durch das All gleiten, ehe es in der Atmosphäre verglüht.
Came an orbiting litter bug.
Okay, they say you got to go for release. Expect 20 pulses on your IC. Hey, no hands.
The wing-like solar array, which she and her partner Tom Akers removed from the Hubble Space Telescope, became space junk after it refused to roll up window shade style as designed.
Looks like a bird, Tom. Look at it.
It fluttered like a bird as Commander Dick Covey fired booster rockets to move Shuttle Endeavour out of harm's way.
Just to watch that thing floating through space was just like 2001, and someday somebody's going to put that to music.
But before the fat lady can sing on this mission, Garage Endeavour must first correct the space telescope's faulty vision. During spacewalk number 3, the other repair duo will begin fitting Hubble with some elaborate prescription glasses. Riding the mechanical arm, Jeff Hoffman will use a handhold to pull out Hubble's primary picture-taking device. It's called the Wide Field and Planetary Camera, or WIFPIC. The Wide Field and Planetary Camera fits like a drawer inside that rectangular space right there. Astronauts will slide out the old camera and then slide in the new one. But that, of course, makes it sound a lot simpler than it really is. A crucial moment will come when Musgrave removes the protective cover from a mirror at the end of WIFPIC 2. If he knocks the mirror out of alignment, the $100 million device will be useless. As it is, the old WIFPIC takes blurry pictures like these, which astronomers correct with computers. A corrective mirror inside the new camera should sharpen the image even more.
When the image is formed reflecting off of this mirror, that image is the image that has the restored full image quality that we expect from the system.
Musgrave and Hoffman will also ride to the top of Hubble to install a pair of new magnetometers, which help the telescope know where the Earth is.
No, I don't hear him.
Except for a temperamental radio, which left Thornton incommunicado from Houston for long spells, Spacewalk number 2 to replace Hubble's solar arrays went according to plan.
And we've been up to bat twice, and our crew has hit 2 home runs, and that's fantastic.
Those new panels have passed their first check. NASA says all the wires are connected properly, but the final test for the solar arrays will come when they try to unroll them during the last spacewalk. Frank?
A lot of work going on here, Miles, and a lot of overtime being put in by the crew if anybody's punching a clock. Concern about fatigue?
So far, no signs of fatigue. NASA has built in an extra day, a day off for the astronauts, which ideally they will take after they've completed all their spacewalks. However, if they're showing signs of being tired, they'll take the day off in the middle.
Okay, Miles O'Brien, thanks very much.